we know that, first of all, between 0 and pi over 2.
You're still sharing?
Oh, yes, of course. I'm sorry. I'll start from scratch. Okay. So I know that between 0 and pi over 2, this graph is definitely this. Before I even perform any calculations, I know that this is 1/4 of a circle, of the area of a circle, which is pi r squared. And I know that this is pi divided by 4, so the radius is pi over 2. So this is pi squared over 4, right? So the area of this circle is pi r squared. Actually, this is 1 and this is pi over 2. I'm jumping ahead for nothing. But in any event, so yeah, let's not talk about this because I was on the wrong track, because it is a circle, and it is 1/4 of a circle, but the radius is here pi over 2 and this is 1, so I cannot use this. Sorry, I was just thinking of a circle for a second. Okay, so it doesn't work because this is pi over 2 and this is 1. If they were both the same, I would have been able to also check my answer like that, but I'm not able to. Okay, so we are asked to use, let me go back for 1 second and see, just make sure it's 4, right? 4 subintervals. Yes, 4 and the right endpoint. Good. What we can do from the beginning, because we already are advanced in this chapter, we can determine the integral from 0 to pi over 2 from sine x dx. That I can do right away. But this is not what they're asking us to do. But I would like to determine the exact area at some point anyway. So why not? This is the easiest thing to do right now. So I know that negative cosine x is the antiderivative of sine, because when I differentiate this function, I get sine. And this will be from 0 to pi over 2. And by the fundamental theorem of calculus, of course, sine is continuous on this interval. I always have to check that. Yes, it is continuous. And I have negative. I plug in pi over 2, which I know it's 0, minus when I plug in 0, I know it's 1. So the exact area must be 1. The reason why I did this is because it's also asking us whether it's an overestimate or an underestimate. But we will determine that not only with finding the area, the exact area, but also in a different way, and I'll explain in a minute. Okay. Since the function is decreasing, sorry. Yes, I know.
Okay.
I know.
Checking.
I just looked at it. I just looked. Yep. You don't have to check. I was just so pi over 2, 1. So this is sine x. Okay. So since the function is increasing, and when I divide this into 4 subintervals, and I'm asked to use the rightmost point, because the function is increasing, this will always be an overestimate. So we already know that. So we're going to get a number that is bigger than 1. 1 is the exact. 1 is the exact area. But here I already know that this will be an overestimate. Why? Because the function is increasing. Okay, so now we have to find delta x. Delta x is the width of the interval, pi over 2 minus 0, so that's pi over 2, divided by 4, because they're asking us to use 4 subintervals. Okay, so this is indeed pi over 8. Good. So the area, the approximate area with right 4 is approximately this, pi over 8. And now I have to determine, because we are using the rightmost point, this, and this. F of this, so pi over 2 divided by 2 is pi over 4. And pi over 4 divided by 2, this is pi over 8. And this is 1 pi, right? So pi over 8 plus pi over 8 plus pi over 8. 3 pi over 8. So I have f of pi over 8 plus f of pi over 4 plus f of 3 pi over 8 plus f of 3 pi over 2. I recommend the following steps with the calculator for this. So I'm going to share my screen. And oops, my calculator is not up. Okay. So in y equals, in lists, we want to edit. I'm going to edit a list. So go to stats, edit, enter, go to the top. I worked with my stats classes on different data sets with the calculator. So clear everything. Go to L1 and clear, and it will clear the whole list for you at once. And I'm going to plug in these x values. Pi over 8, make sure that you are in radian mode. Okay, so back to my stats and edit. And I want pi over 8. I want pi over 4. I want 3 pi over 8. Although we don't need parentheses, I prefer it. And the last one is 3 pi, and not 3 pi over 2, it's just pi over 2, of course. Pi over 2 is the last one. Pi divided by 2. Okay. Now, enter, and go and highlight L2, just the top of L2. And all I would like you to write is, now, in parentheses, pi divided by 8, which is delta x in front, multiplied by sine of list L1. So what will the calculator do? Multiply pi over 8 by sine of this and put it here. Multiply pi over 8 by sine of this and put it here. And so on and so forth. So you're still highlighting at the top, L2, pi over 8 in parentheses, sine list L1. Boom. What I want now is I want the calculator to sum these up. So I go to stats and calculations, one variable stats for list L2, not L1. I don't need any frequency and calculate. And look at this symbol. Here it is. Here's the sum of all those areas with 2, 4, 6, 9 decimals. So this is 1.183465. Do not choose this by mistake. That's the mean. That's a totally different story. This is the sum of x squared. That's a totally different story. Standard deviation for the sample, standard deviation for the population. There is no need for any of that. That's all you need, the sum. And go back to the question. Is it an underestimate? I didn't even need to calculate the 1, as we already know with fundamental theorem of calculus, part 2. I didn't need that, right? I know because the function is increasing. The function is increasing, and if I use the rightmost point, it will always be an overestimate. If the function is increasing and I use the leftmost point, it will always be an underestimate. So it all depends on sign of the function, if it's increasing or decreasing.
I have a question.
Yes, I'm ready.
Is there a way you can record the calculator?
The problem I'm having with that, yes, the problem I'm having with that is I cannot change it into a YouTube video. And this camera does not allow me to record because you see, I mean, Zoom knows that this is the camera I use to visual, for you to see. And that's the reason why I have this camera on that device recording. But I can go through the steps, and if you want to write them down, very simple. Once you do it once, you'll have no problem. If you want to write them down, is that okay?
Yeah, I'll write them down.
Sure. Okay, so we do this. So we go to stat. So stat is number 1. Number 2 is edit. Enter. In list L1, you type in the x values. In our case, pi over 8, pi over 4, 3 pi over 8, and pi over 2. And in list L2, you put what you need at the very top. Like, in our case, we had pi over 8, which was delta x, and then sign of the list L1. It will always be a function of the list L1. And when you press enter, you will get all these numbers. And now one option would be to add them up, but you can't. You have to use a different, you can't. You have to use a different calculator, right? So once you have this, you go back to stats, calculations, one variable stats. And just make sure that your list is the one that you want to add the numbers for, not list L1. You don't want the sum for list L1, you want the sum for list L2. And then calculate. Try it once if you like. Maybe we can spend some time after class and we can, create another list.
Okay.
Were you able to jot that down? Do you want me to go back through it?
Yeah, I wrote it down.
Okay. Okay.
Thank you.
Thank you. Anytime. And if you have some time, anyone, always, as you remember, I always beg you to stay if you have any questions. Good. That was a very good question. Thank you. I wanted to show that, and I didn't get the chance to show it last time. Perfect. Anything else you would like to go back to? I don't know. The light today is not that good here. I'm not sure what am I doing differently. Okay. Any questions? Anyone? Were you able to follow this? Yes? No? Anything else from WebAssign? Anything else from written homework that you would like to go back to? Anything? Okay, in that case, I would like to go back and list properties of definite integral. We do have one already for the odd even. We already listed that. Number 2. The integral, let's suppose we have this function f of x, and we have the interval between a and b. And obviously, this area is the integral. So the area is the integral from a to b from f of x dx, as we learned already. But if I have a number c anywhere here, anywhere between a and b, then the integral from a to b from f of x dx, of course, it will be a sum of two integrals, from a to c and from c to b. So basically what I'm saying here is you can break the integral of a continuous function, absolutely continuous, continuous on a comma b. You can break the interval anywhere you want. You can create more than two integrals. You can have d here, a to c plus c to d plus d to b. So that's another property. Moving on to property 3. Let me push my device over there. Maybe that's what the light is. Okay, so the integral from a to a from f of x dx. What do you think this equals to? A wild guess.
Be 0?
Of course, there is no interval. So the integral from 1 to 1, there is no width. It's a 0 width. In other words, if you want dx is 0. Very good. The integral from a to b from f of x dx is the opposite of the integral from b to a from f of x dx. That's another property. Moving on. Property 5. So let's suppose I have two functions. I have function f of x, and I have function g of x on the interval a comma b. Now, here's my question to you. Would you agree that on a comma b, it appears that f of x from my graph is greater than or equal to g of x? Also can be written as g of x is less than or equal to f of x. Would you agree with that?
Yes.
Good. Which means the integral from a to b from g of x dx must be less than or equal to y, because the area under this graph has to be bigger than the area under this graph. So if g of x is less than or equal to f of x, the area under g has to be smaller than the area under f. So that's another property. Okay, let's look at number 6. Stop me if you have questions. You know that, right? Any questions so far? Anything? Okay, so let's suppose I have a constant, y equals m, like a line. And then let's say I have another one somewhere up here. And y equals m, uppercase m. And let's say the function is somewhere here. This is f of x on the interval a comma b. Very similar. That's why I always present this before this. I can say it's obvious right? I wanted to start by writing on a comma b. That's where the a was coming from. So on the interval a comma b, it's very clear from the graph that the function, it's not the squeeze theorem, but the function is somewhere in between upper m and lower m. So then what do you think I'm going to do? A wild guess. What do you think I'm going to do to all three sides of this compound inequality? What do you think? Well, it's all about areas, right?
Yeah, I was gonna say that.
Thank you so much. The middle part is the integral from a to b from f of x dx. But the other side the sides can be determined. What is this is a constant, goes in front. What is the antiderivative of 1? Because m goes outside. Or you can say, I don't need your antiderivative, because I can determine this area is m times b minus a. And so is this. Of course, it's uppercase m times b minus a. Base times height. Base times height. So that's another property of the definite integral.